Dear students, करंट इलैक्ट्रिसिटी एंड रेजिस्टेंस की एक अति इंपॉर्टेंट क्लास विच तुहाडा स्वागत है। अज असीं ओम्स लॉ पढ़ांगे। Before I recall its statement and build the concept, have a look at the learning objectives of this lesson.
Describe Ohm's law and its limitations. Describe resistance and resistivity. Define electrical conduction, conductivity, and electrical power.
Ohm's law ਦੇ ਅਨੁਸਾਰ ਕਿਸੇ ਕੰਡਕਟਰ ਵਿੱਚੋਂ ਫਲੋ ਕਰਦਾ ਕਰੰਟ I ਕੰਡਕਟਰ ਦੇ ਦੋਨੋਂ ਐਂਡਸ ਦੇ ਅਕ੍ਰੋਸ ਪੋਟੈਂਸ਼ੀਅਲ ਡਿਫਰੈਂਸ V ਦੇ ਡਾਇਰੈਕਟਲੀ ਪ੍ਰੋਪੋਰਸ਼ਨਲ ਹੁੰਦਾ ਹੈ, ਬਸ਼ਰਤੇ ਕੰਡਕਟਰ ਦੀਆਂ ਫਿਜ਼ੀਕਲ ਕੰਡੀਸ਼ਨਸ ਜਿਵੇਂ ਟੈਂਪਰੇਚਰ, ਮੈਕੈਨੀਕਲ ਸਟ੍ਰੇਨ ਆਦਿ ਨਾ ਬਦਲਣ। This means I is proportional to V or V is proportional to I or V is equal to R into I or V upon I is equal to R, which is equal to a constant. Constant R कंडक्टर दी रेजिस्टेंस के नाम नाल जानिया जाता है। ये कंडक्टर दी लेंथ, शेप अते नेचर ऑफ द मटीरियल ते डिपेंड करती है।
किसी कंडक्टर लई पोटेंशियल डिफरेंस अते करंट दे विचकार वेरिएशन करंट वर्सेस पोटेंशियल ग्राफ ते ड्रॉ कीती जा सकती है। ये ग्राफ एक स्ट्रेट लाइन हुंदा है।
ये जानना जरूरी है कि कोई भी कंडक्टिंग डिवाइस ओम्स लॉ की पालना ताही करती है जे इसकी रेजिस्टेंस, इसके मैग्नीट्यूड अते अप्लाइड पोटेंशियल डिफरेंस की पोलैरिटी तो इंडिपेंडेंट होवे। रेजिस्टेंस एक इंपॉर्टेंट फिजिकल क्वांटिटी है अते इसनू डिफाइन करना जरूरी है। The resistance of a conductor is the obstruction posed by the conductor to the flow of electric current through it. Resistance R of a conductor is defined as the ratio of the potential difference across the ends of the conductor to the current flowing through it. That is, R is equal to V upon I, if V and I represent the potential difference and the current respectively. The SI unit of resistance is ohm, where 1 ohm is equal to 1 volt upon 1 ampere. The dimensions of electric resistance are m raised to the power 1, L raised to the power 2, T raised to the power minus 3, A raised to the power minus 2. Can you think of the possible cause of the resistance of a conductor? Let me show and explain this to you.
Conducting wire ਦੀ resistance ਨੂੰ ਇੱਕ closed water pipe ਨਾਲ compare ਕਰਦੇ ਹਾਂ, ਜਿਸ ਵਿੱਚ fixed motor ਪਾਣੀ ਦੇ flow ਨੂੰ ਬਿਲਕੁਲ ਉਸੇ ਤਰ੍ਹਾਂ govern ਕਰ ਰਹੀ ਹੈ ਜਿਵੇਂ ਇੱਕ electric circuit ਵਿੱਚ battery current ਦੇ flow ਨੂੰ govern ਕਰਦੀ ਹੈ। ਪਾਈਪ ਵਿੱਚ ਕੁਝ ਰੋੜੇ ਪਏ ਹਨ ਜਿਹੜੇ ਪਾਣੀ ਦੇ ਫਲੋ ਵਿੱਚ ਆਬਸਟੈਕਲਸ ਜਾਂ ਰੈਜ਼ਿਸਟੈਂਸ ਦਾ ਕੰਮ ਕਰਦੇ ਹਨ। ਹੁਣ ਦੇਖੋ, ਇਹ ਇੱਕ ਇਲੈਕਟ੍ਰਿਕ ਸਰਕਿਟ ਰਿਪਰੈਜ਼ੈਂਟ ਕਰ ਰਿਹਾ ਹੈ। ਕੰਡਕਟਰ ਦੀ ਰੈਜ਼ਿਸਟੈਂਸ ਕੰਡਕਟਰ ਦੇ ਫਿਜ਼ੀਕਲ ਪੈਰਾਮੀਟਰਸ ਤੇ ਵੀ ਡਿਪੈਂਡ ਕਰਦੀ ਹੈ। ਇਹਨਾਂ ਚੋਂ ਪਹਿਲਾ ਹੈ ਕੰਡਕਟਰ ਦੀ ਲੈਂਥ। ਇੱਥੇ ਦੇਖੋ, ਜੇਕਰ ਪਾਈਪ ਦੀ ਲੰਬਾਈ ਵਧਾ ਦਿੱਤੀ ਜਾਵੇ ਤਾਂ ਪਾਣੀ ਨੂੰ ਵੱਧ ਆਬਸਟੀਕਲਸ ਫੇਸ ਕਰਨੇ ਪੈਣਗੇ ਜਾਂ ਤੁਰਨ ਲਈ ਜ਼ਿਆਦਾ ਮਿਹਨਤ ਕਰਨੀ ਪਵੇਗੀ। ਇਸੇ ਤਰ੍ਹਾਂ ਕੰਡਕਟਰ ਦੀ ਰੈਜ਼ਿਸਟੈਂਸ ਵੀ ਲੈਂਥ, ਜਿਸ ਨੂੰ ਸਮਾਲ l ਨਾਲ ਦਰਸਾਇਦਾ ਹੈ, ਤੇ ਡਿਪੈਂਡ ਕਰਦੀ ਹੈ। ਇਹ ਕੰਡਕਟਰ ਦੀ ਲੈਂਥ ਦੇ ਡਾਇਰੈਕਟਲੀ ਪ੍ਰੋਪੋਰਸ਼ਨਲ ਹੁੰਦੀ ਹੈ, ਯਾਨੀ ਜੇ ਕੰਡਕਟਰ ਦੀ ਲੰਬਾਈ ਡਬਲ ਕਰ ਦਿੱਤੀ ਜਾਵੇ ਤਾਂ ਇਸ ਦੀ ਰੈਜ਼ਿਸਟੈਂਸ ਵੀ ਡਬਲ ਹੋ ਜਾਵੇਗੀ। ਦੂਜਾ ਫੈਕਟਰ ਹੈ ਕੰਡਕਟਰ ਦਾ ਏਰੀਆ ਆਫ ਕ੍ਰਾਸ ਸੈਕਸ਼ਨ, ਜਿਹੜਾ ਕੈਪੀਟਲ A ਨਾਲ ਲਿਖੀਦਾ ਹੈ। ਏਰੀਆ ਆਫ ਕ੍ਰਾਸ ਸੈਕਸ਼ਨ A ਜੇਕਰ ਪਾਈਪ ਦੀ ਥਿਕਨੈਸ ਵਧਾ ਦਿੱਤੀ ਜਾਵੇ ਤਾਂ ਪਾਣੀ ਨੂੰ ਤੁਰਨ ਲਈ ਜ਼ਿਆਦਾ ਖੁੱਲ੍ਹਾ ਥਾਂ ਮਿਲ ਜਾਵੇਗਾ ਅਤੇ ਘੱਟ ਮਿਹਨਤ ਕਰਨੀ ਪਵੇਗੀ। ਬਿਲਕੁਲ ਇਸੇ ਤਰ੍ਹਾਂ ਕੰਡਕਟਰ ਦੀ ਰੈਜ਼ਿਸਟੈਂਸ ਵੀ ਇਸ ਦੇ ਏਰੀਆ ਆਫ ਕ੍ਰਾਸ ਸੈਕਸ਼ਨ ਦੇ ਇਨਵਰਸਲੀ ਪ੍ਰੋਪੋਰਸ਼ਨਲ ਹੁੰਦੀ ਹੈ। ਯਾਨੀ ਜੇ ਕੰਡਕਟਰ ਦੀ ਥਿਕਨੈਸ ਡਬਲ ਕਰ ਦਿੱਤੀ ਜਾਵੇ ਤਾਂ ਇਸ ਦੀ ਰੈਜ਼ਿਸਟੈਂਸ ਪਹਿਲਾਂ ਨਾਲੋਂ ਅੱਧੀ ਰਹਿ ਜਾਵੇਗੀ। ਇਸੇ ਤਰ੍ਹਾਂ ਕੰਡਕਟਰ ਦੀ ਥਿਕਨੈਸ ਘਟਾਉਣ ਨਾਲ ਇਸ ਦੀ ਰੈਜ਼ਿਸਟੈਂਸ ਵੱਧ ਜਾਵੇਗੀ। ਕਿਸੇ ਕੰਡਕਟਿੰਗ ਵਾਇਰ ਦੀ ਰੈਜ਼ਿਸਟੈਂਸ ਦਾ ਮੁੱਖ ਕਾਰਨ ਹੈ ਉਸ ਵਿਚਲੇ ਫ੍ਰੀ ਇਲੈਕਟ੍ਰੌਨਸ ਦਾ ਪੋਜ਼ਿਟਿਵ ਐਂਡ ਵੱਲ ਡ੍ਰਿਫਟ ਕਰਦਿਆਂ ਹੋਇਆ ਕੰਡਕਟਰ ਦੇ ਹੀ ਆਇਨਸ ਜਾਂ ਐਟਮਸ ਨਾਲ ਕੋਲਿਜ਼ਨਸ। ਫਿਰ ਇਹ ਸਾਰਾ ਕੁਝ ਡਿਪੈਂਡ ਕਰਦਾ ਹੈ ਕੰਡਕਟਿੰਗ ਮਟੀਰੀਅਲ ਵਿੱਚ ਐਟਮਸ ਦੀ ਅਰੇਂਜਮੈਂਟ ਯਾਨੀ ਨੇਚਰ ਆਫ ਮਟੀਰੀਅਲ ਉੱਤੇ।
Besides length, area of cross section and nature of the material, the resistance of a conductor also depends upon its nature. We will discuss this after learning the mathematical equation of the facts studied so far. Considering the effects of length and area of cross section on the resistance of a conductor, we write R is proportional to L by A, or R is equal to rho into L by A, where rho is the constant of proportionality and is known as specific resistance or electrical resistivity of the material of the conductor. Now, if L be equal to unit length and A also be equal to unit area, then R will be equal to rho. Thus, specific resistance or electrical resistivity of the material of a conductor is defined as the resistance offered by unit length and unit area of cross section by a wire of the given material of conductor. That is, it is also defined as the resistance of unit cube of a material of the given conductor. Knowing this much about resistivity is just not enough. We need to know its unit as well. From the equation R is equal to rho into L by A, we can write rho is equal to R into A by L. Therefore, in SI, unit of resistivity will be equal to ohm meter square upon meter. This turns out to be ohm meter. The value of electrical resistivity varies over a wide range for different materials. In general, electrical resistivity is very low for conductors and very high for insulators. The values of resistivities of some metals, their alloys, semiconductors and insulators can be seen in this table. It must be noted that the resistivity of metals is very low as compared to resistivity of alloys, which is still much more lower than that of semiconductors. Also, the resistivities of insulators are much higher than that of these substances. The substances having their electrical resistivity between that of conductors and insulators are called semiconductors. Copper is a common material used for making electrical wires because of its very low electrical resistivity. Also, thin wires of alloys like manganese and constantan are used to make standard resistances because of their very high electrical resistivity. Before continuing further, I'd like to stress upon some distinguishing features of resistance and resistivity so that you have a clear understanding of both of the terms separately. Resistance of a conductor depends upon the dimensions, that is, length and area of cross section and nature of material of the conductor. But resistivity depends on nature of the material only. and is independent of the dimensions of the conductor. Also, resistance is a property of an object. Resistivity is a property of the material. Ohm meter is the unit of resistivity, whereas ohm meter is an instrument to measure the resistance. We will now understand two new terms known as conductance and electrical conductivity. Well, as the name suggests, the reciprocal of the resistance of a conductor is called its conductance, which is denoted by capital G. Therefore, symbolically we can write G is equal to 1 by R. The SI unit of conductance is ohm inverse or mho. Then the reciprocal of the resistivity of the material of a conductor is called its conductivity. This is denoted by sigma. So, it can be written as sigma equal to 1 by rho. This equation implies that the unit of conductivity is reciprocal of the unit of resistivity. Hence, SI unit of conductivity is ohm inverse meter inverse. The SI unit of conductivity is mho meter inverse. On the basis of conductivity, the materials can be classified into these categories. Insulators. ਇਹ ਉਹ ਮਟੀਰੀਅਲਸ ਹਨ ਜਿਨ੍ਹਾਂ ਦੀ ਇਲੈਕਟ੍ਰੀਕਲ ਕੰਡਕਟਿਵਿਟੀ ਜਾਂ ਤਾਂ ਬਹੁਤ ਲੋ ਹੈ ਜਾਂ ਬਿਲਕੁਲ ਹੀ ਨਾ ਬਰਾਬਰ ਹੈ। ਪ੍ਰੈਕਟੀਕਲੀ ਇਨਸੂਲੇਟਰਸ ਚਾਰਜ ਕੰਡਕਟ ਨਹੀਂ ਕਰਦੇ। ਜੇ ਇੱਕ ਇਨਸੂਲੇਟਰ ਦੇ ਐਂਡਸ ਦੇ ਅਕ੍ਰੋਸ ਸਮਾਲ ਪੋਟੈਂਸ਼ੀਅਲ ਡਿਫਰੈਂਸ ਅਪਲਾਈ ਕੀਤਾ ਜਾਵੇ ਤਾਂ ਇਸ ਵਿੱਚ ਨੈਗਲੀਜੀਬਲੀ ਸਮਾਲ ਕਰੰਟ ਫਲੋ ਕਰੇਗਾ। ਉਦਾਹਰਣ ਲਈ ਗਲਾਸ, ਰਬਰ, ਵੁੱਡ ਆਦਿ। ਕੰਡਕਟਰਸ ਉਹ ਮਟੀਰੀਅਲਸ ਹਨ ਜਿਨ੍ਹਾਂ ਦੀ ਇਲੈਕਟ੍ਰੀਕਲ ਕੰਡਕਟਿਵਿਟੀ ਬਹੁਤ ਹਾਈ ਹੁੰਦੀ ਹੈ। ਇਹ ਬੜੀ ਆਸਾਨੀ ਨਾਲ ਚਾਰਜ ਕੰਡਕਟ ਕਰਦੇ ਹਨ। ਜੇ ਇੱਕ ਕੰਡਕਟਰ ਦੇ ਐਂਡਸ ਦੇ ਅਕ੍ਰੋਸ ਸਮਾਲ ਪੋਟੈਂਸ਼ੀਅਲ ਡਿਫਰੈਂਸ ਅਪਲਾਈ ਕੀਤਾ ਜਾਵੇ ਤਾਂ ਇਸ ਵਿੱਚ ਸਟਰੋਂਗ ਕਰੰਟ ਫਲੋ ਕਰੇਗਾ। ਉਦਾਹਰਣ ਲਈ ਕਾਪਰ, ਸਿਲਵਰ, ਐਲੂਮੀਨੀਅਮ, ਟੰਗਸਟਨ ਆਦਿ। ਮਟੀਰੀਅਲਸ ਦੀ ਇੱਕ ਹੋਰ ਕੈਟੇਗਰੀ ਹੈ ਜਿਹੜੀ ਸੁਪਰ ਕੰਡਕਟਰਸ ਕਹਾਉਂਦੀ ਹੈ। ਇਹ ਉਹ ਮਟੀਰੀਅਲਸ ਹਨ ਜਿਨ੍ਹਾਂ ਦੀ ਇਲੈਕਟ੍ਰੀਕਲ ਕੰਡਕਟਿਵਿਟੀ ਦੀ ਵੈਲਿਊ ਇਨਫਾਈਨਾਈਟ ਹੁੰਦੀ ਹੈ। ਫਿਰ ਸੈਮੀਕੰਡਕਟਰਸ ਉਹ ਮਟੀਰੀਅਲਸ ਹਨ ਜਿਨ੍ਹਾਂ ਦੀ ਇਲੈਕਟ੍ਰੀਕਲ ਕੰਡਕਟਿਵਿਟੀ ਇਨਸੂਲੇਟਰਸ ਅਤੇ ਕੰਡਕਟਰਸ ਦੀ ਇਲੈਕਟ੍ਰੀਕਲ ਕੰਡਕਟਿਵਿਟੀਜ਼ ਦੇ ਵਿਚਕਾਰ ਹੁੰਦੀ ਹੈ। ਜੇ ਇੱਕ ਸੈਮੀਕੰਡਕਟਰ ਦੇ ਐਂਡਸ ਦੇ ਅਕ੍ਰੋਸ ਸਮਾਲ ਪੋਟੈਂਸ਼ੀਅਲ ਡਿਫਰੈਂਸ ਅਪਲਾਈ ਕੀਤਾ ਜਾਵੇ ਤਾਂ ਇਸ ਵਿੱਚ ਚਾਰਜ ਕੈਰੀਅਰਸ ਦੇ ਮੋਸ਼ਨ ਕਾਰਨ ਇੱਕ ਵੀਕ ਕਰੰਟ ਫਲੋ ਕਰੇਗਾ। ਉਦਾਹਰਣ ਲਈ ਜਰਮੈਨੀਅਮ, ਸਿਲੀਕਨ ਆਦਿ। ਆਓ ਹੁਣ ਤੁਹਾਨੂੰ ਇਫੈਕਟ ਆਫ ਟੈਂਪਰੇਚਰ ਔਨ ਰੈਜ਼ਿਸਟੈਂਸ ਦੱਸੀਏ।
ਜਦੋਂ ਮੈਟਲ ਕੰਡਕਟਰ ਦਾ ਟੈਂਪਰੇਚਰ ਵਧਾਇਆ ਜਾਂਦਾ ਹੈ, ਇਸ ਦੇ ਆਇਨਸ ਜਾਂ ਐਟਮਸ ਆਪਣੀ ਮੀਨ ਪੋਜੀਸ਼ਨ ਦੁਆਲੇ ਮੀਨ ਲੈਟਿਸ ਸਾਈਟਸ ਤੋਂ ਜ਼ਿਆਦਾ ਐਂਪਲੀਟਿਊਡ ਅਤੇ ਜ਼ਿਆਦਾ ਫ੍ਰੀਕੁਐਂਸੀਜ਼ ਨਾਲ ਵਾਈਬ੍ਰੇਟ ਕਰਦੇ ਹਨ। ਥਰਮਲ એનર્ਜੀ ਵਿੱਚ ਇਨਕਰੀਜ਼ ਹੋਣ ਕਾਰਨ ਕੰਡਕਟਰ ਦੇ ਪੋਜ਼ਿਟਿਵ ਐਂਡ ਵੱਲ ਜਾਂਦੇ ਫ੍ਰੀ ਇਲੈਕਟ੍ਰੌਨਸ ਦੀ ਕੋਲਿਜ਼ਨ ਦੀ ਫ੍ਰੀਕੁਐਂਸੀ ਵੀ ਵੱਧ ਜਾਂਦੀ ਹੈ। ਇਸ ਤਰ੍ਹਾਂ ਰਿਲੈਕਸੇਸ਼ਨ ਟਾਈਮ ਟਾਓ ਘਟ ਜਾਂਦਾ ਹੈ, ਪਰ ਟੈਂਪਰੇਚਰ ਚੇਂਜ ਹੋਣ ਨਾਲ ਮੈਟਲ ਕੰਡਕਟਰ ਵਿੱਚ ਇਲੈਕਟ੍ਰੌਨਸ ਦੀ ਡੈਂਸਿਟੀ ਵਿੱਚ ਕੋਈ ਖਾਸ ਫਰਕ ਨਹੀਂ ਪੈਂਦਾ। Hence, the value of resistance increases with rise of temperature. Thus, temperature coefficient of resistance is defined as the increase in resistance per unit original resistance per degree rise of temperature.
The resistivity is related to two parameters of the material, namely the number density n of free electrons in the material and relaxation time tau. the variation of resistivity of material with temperature is different in different materials. In most metals, number density N of free electrons does not change with temperature, but an increase in temperature increases the amplitude of vibration of lattice ions of the metal and thermal speed of the electrons, which act as carriers of current. Due to this, the collision of free electrons with ions or atoms while drifting towards the positive end of the conductor becomes more frequent, resulting in a decrease in relaxation time. Hence, resistivity of conductor increases with increase in temperature. For most metals, the resistivity increases linearly with increase in temperature over a temperature range of about 500 Kelvin above the room temperature. For semiconductors like carbon, germanium, silicon, etc., with increase in temperature, the number density N increases, but time of relaxation decreases. For semiconductors, resistivity decreases with temperature. In insulators, the resistivity increases exponentially with decrease in temperature. It becomes infinitely large at temperature near absolute zero. That is, the conductivity of insulator is almost zero at 0 Kelvin. It is important to know that all materials and objects do not follow the Ohm's law. There are certain objects which do not obey the Ohm's law or display the so-called failures of Ohm's law. These conductors which do not obey Ohm's law are called non-ohmic conductors. For example, vacuum tubes, semiconductor diode, liquid electrolyte, transistor, etc. The relation V upon I equal to R is valid for ohmic and non-ohmic conductors. The value of R is constant for ohmic conductors, but not so for non-ohmic conductors. That is, Ohm's law fails when V by I is not constant. For all non-ohmic conductors, the VI graph has one or more of these three characteristics. First, the relation between V and I is nonlinear as shown here. Secondly, the relation between V and I depends on the sign of V. It means that if I is the current for a certain value of V, then reversing the direction of V, keeping its magnitude fixed, does not produce a current of same magnitude I as in the opposite direction. This happens in case of junction diode, which we shall study later in this class. Thirdly, the relation between V and I is not unique. That is, there is more than one value of V for the same current I. This happens for a light emitting diode. After having learned so much about the resistors, it is time to understand basic concept of electrical energy. The total work or energy supplied by the source of EMF in maintaining the electric current in the circuit for a given time is called electric energy consumed in the circuit. Most of the times, this energy is exhibited in the form of heat energy. A scientist named Joule studied the heating effect of electric current in 1841. It was found by him that there are basically three factors affecting the amount of heat produced in a conductor due to current flowing through it. These are: the amount of heat is directly proportional to the square of the current flowing through the conductor. If Q represents the amount of heat and I the current, the proportionality can be written as Q proportional to I square. Second, the amount of heat is directly proportional to the resistance of the conductor, Q proportional to R. And third, the amount of heat is directly proportional to the time for which the current flows in the conductor, Q proportional to T. Combining the effect of all the three factors, we can write Q is proportional to I square RT, which can be written as Q is equal to I square RT upon J, where J is known as the Joule's mechanical equivalent of heat. The value of J is 4.18 Joule per calorie. In SI system, the heat produced due to electric current is expressed in joules by the equation Q equal to I square RT. Electric power. ਹੁਣ ਬਾਰੀ ਹੈ ਇੱਕ ਹੋਰ ਨਵੀਂ ਟਰਮ ਇੰਟਰੋਡਿਊਸ ਕਰਨ ਦੀ, ਜਿਹੜੀ ਹੈ ਇਲੈਕਟ੍ਰਿਕ ਪਾਵਰ। ਜੇ ਤੁਹਾਨੂੰ ਛੋਟੀਆਂ ਕਲਾਸਾਂ ਵਿੱਚ ਪੜ੍ਹੀ ਪਾਵਰ ਦੀ ਡੈਫੀਨੇਸ਼ਨ ਯਾਦ ਹੋਵੇ ਤਾਂ it is defined as the amount of work done per unit time ਅਤੇ ਇਸ ਦੀ SI unit watt ਹੈ। ਇਲੈਕਟ੍ਰਿਕ ਪਾਵਰ ਦੇ ਕੇਸ ਵਿੱਚ ਵੀ ਡੈਫੀਨੇਸ਼ਨ ਤੇ SI unit ਸੇਮ ਹੀ ਹਨ। The rate at which the electric work is done by the source of EMF in maintaining the current in electric circuit is called electric power of the circuit. If a current I ampere flows through a conductor of resistance R for a time t second under a potential difference of V volt, then electric work done to maintain the current is given by W equal to V into I into T joule. Therefore, electric power P is equal to W upon T, which is equal to V into I into T upon T. This is further equal to VI watt or joule per second. So, it can be said that power in watt is equal to V in volt into I in amperes. The unit of power, that is watt, can be defined from this equation. The power of an electric circuit is said to be 1 watt if 1 ampere current flows in it against a potential difference of 1 volt. Bigger units of power are kilowatt and megawatt, where 1 kilowatt equal to 1000 watt and 1 megawatt is equal to 10 raised to the power 6 watts. An old commercial unit of power used to be horsepower, where 1 horsepower is equal to 746 watts. Using the Ohm's law, the equation for electric power can also be written as P equal to VI, which can also be written as P equal to I square into R and also equal to V square by R. The source of this power is an external source to keep a steady current through the conductor. In a simple circuit where the current is supplied to a conductor by the cells, it is the chemical energy of the cells which supplies the power for as long as it can. It is enough of talking we have had about electric work done and the electric power. We have got some more to share about the electrical energy with you. First, we will redefine electrical energy. The total electric work done or energy supplied by the source of EMF in maintaining the current in an electric circuit for a given time is called electric energy consumed in the circuit. Therefore, electric energy W is equal to V into I into T or P into T, which implies electric energy is equal to electric power into time. SI unit of electric energy is joule, where 1 joule is equal to 1 volt into 1 ampere into 1 second, which is equal to 1 watt into 1 second. The commercial unit of electric energy is called a kilowatt hour or Board of Trade unit or BOT or unit of electricity in brief, where 1 kilowatt hour is 1 kilowatt into 1 hour, which can be written as 1000 watt into 1 hour. Thus, it can also be said that 1 kilowatt hour is the total electric energy consumed when an electrical appliance of power 1 kilowatt works for 1 hour. So, 1 kilowatt hour is equal to 1000 watt hour. This is equal to 1000 watts into 60 seconds, which comes out to be 3.6 into 10 raised to the power 6 joule. It is worth noticing here that the number of units of electricity consumed is equal to number of kilowatt hours or is equal to the product of watts and number of hour divided by 1000. Remember, to calculate the electrical energy, we use the formula energy W equal to power into time. And the formulae used for calculating power are P equal to VI, P equal to I square into R, and also P equal to V square by R. Henceforth, the formulae used for calculating energy are W equal to V into I into T, W equal to I square into R into T, and W equal to V square into T by R respectively. And now, let me bring the lesson to an end by quickly summarizing the main points of today. According to Ohm's law, at constant physical conditions like temperature, mechanical strain, etc., the current flowing through a conductor is always directly proportional to the potential difference across its ends. Mathematically, V is equal to IR, where R is the resistance of the conductor, where the resistance of a conductor is the obstruction posed by the conductor to the flow of electric current through it. The SI unit of resistance is ohm. Specific resistance or electrical resistivity of the material of a conductor is defined as the resistance offered by unit length and unit area of cross section by a wire of the given material of conductor. SI unit of resistivity is ohm meter. The reciprocal of the resistance of a conductor is called its conductance. The reciprocal of the resistivity of the material of a conductor is called its conductivity. The rate at which the electric work is done by the source of EMF in maintaining the current in electric circuit is called electric power of the circuit. The commercial unit of electrical energy is called a kilowatt hour. Now, let's see if you can answer some simple questions from today's lesson. The first question is, define Ohm's law. The answer is, Ohm's law states that the physical conditions like temperature, mechanical strain, etc. remaining unchanged, the current flowing through a conductor is always directly proportional to the potential difference across its ends. The next question is, what do you understand by resistivity? The answer is, resistivity of a material is the resistance offered by unit length and unit area of cross section by a wire of the given material of conductor. Another question is, what do you understand by BOT? The answer is, BOT or Board of Trade unit is the commercial unit of electric energy equal to 1 kilowatt hour. Next question is, what do you understand by 1 watt? The answer is, The power of an electric circuit is said to be 1 watt if 1 ampere current flows in it against a potential difference of 1 volt. Ohm's law ਅਤੇ electrical energy ਦਾ ਇਹ important concept ਤੁਹਾਨੂੰ easy ਅਤੇ interesting ਲੱਗਿਆ ਹੋਵੇਗਾ। ਇਸ ਆਸ ਨਾਲ ਅੱਜ ਦਾ ਲੈਸਨ ਸਮਾਪਤ ਕਰਦੇ ਹਾਂ। See you in the next class and goodbye until then.